All right, so the previous examples were kind of baby steps. Now we're all grown up. On example 5 here, find all functions g such that g prime of x is equal to 4 sine x plus what? 2x to the fifth minus the square root of x all divided by x. Are you kidding me? Okay, well, of course, this thing is called a differential equation. It's a differential equation because, hey, we've got this g prime that's right up in here. How do I solve a differential equation? What's the goal? It is to find the original function g of x, and I do that by antidifferentiation, otherwise known as integration, or specifically indefinite integration. There's another kind of integration, which is called definite integration. We're not quite there yet. That's going to be what the next couple of lessons is all about. But so I'm going to need a little bit of room to work this one because look at it, right? It's got this quotient in here. Now, I want you to remember back when we were writing down some anti-differentiation rules, at no point did we write down one for a quotient. No, we sure didn't. Matter of fact, we didn't write down one for products either. Curious, right? Okay, so what this means is that I have to try to avoid any kind of quotients or products by, yeah, I think I can just divide this x into both of these pieces here. I think I can accomplish that. So here, let's just rewrite this. G prime of x is equal to, bring down the 4 sine x, that's fine, but plus, take this x divided into 2x to the fifth and get 2x to the fourth minus, and of course this is x to the 1/2, minus x to the 1 is going to be x to the negative 1/2. Now, let's term by term take the antiderivative. So our derivative, instead of capitalizing this, if my derivative is called g prime, then its original function must be called g of x. So here's kind of in general what you do. When you're finding the antiderivative, if there's already a prime mark on there, you just take it off. But if there's not, let's say it's, keep riding with the laser. Let's just say that your function is g of x and you're trying to find the antiderivative of it. Well, to indicate that, since there's no prime mark to take off, that's when we capitalize the thing like that, okay? All right, then. So, term by term, taking the antiderivative. What's the antiderivative of sine? It's cosine. But it's a cofunction, so let's make it negative. Negative for cosine x, okay, plus 2x to the, add 1 to the exponent 5, then divide by that new exponent 5, minus x to the, let's add 1 to that exponent, is going to be, let's see, negative 1/2 plus 1 is positive 1/2. Divide by that new exponent, 1/2. And then don't forget the constant of integration. And one last thing is just maybe clean this up a little bit. I can rewrite this as a square root. It originally started with a square root, and bring this 1/2 up to the top to make it positive 2. Well, no, still negative 2. Yeah. Okay. So one last go. G of x is equal to negative 4 cosine x plus 2/5 x to the fifth, and then minus 2 square root of x plus c. So notice that when we found, or when we solved this differential equation, when we found its antiderivative, we actually found an infinite number of solutions. This plus c, in most instances, in this particular instance, it does translate this function up and down, and I have no idea what the original function was without an additional piece of information called an initial value. And that's exactly what it is that we're going to do next here. In order to find a particular solution, which is what it's called, you have to know a point on the original curve. And up until this point, we haven't done that. All we've been able to find is the general solution to any given differential equation. But if we had an initial condition, we can find the particular solution. So here's an example over here with some pictures here. You can see that you have a general antiderivative right here, x cubed minus x plus c. And through a given point, this 2, 4, there's only one of those curves that actually exists. So you can solve for that plus c. So here's the differential equation that we must have started with, that f prime is equal to 3x squared minus 1. So working backwards to find the antiderivative of that thing, let's see, I would add 1 to the exponent's 3, divide by the 3, so the 3's would cancel out, so I'd have just x cubed, and then minus x plus the c. Okay, so in order to find a particular solution, we needed to have a point that's on that curve, which is called an initial condition. So what we'll do is we will plug 2 in for all the x's, and we'll set y, or f of x, equal to 4 so that we can solve it for that c, right? That's essentially what you do in order to find that particular solution. And once you do, you can solve it for a c value of -2. You want to give that a try? Let's give that a try here on example 6. Find the general solution of f prime of x is equal to 1 over x cubed, given that x is greater than 0, and find the particular solution that satisfies the initial condition that f of 1 is equal to 0. So kind of a two-step process here. We're going to find the general solution first, and then once we do, we have an initial condition, we can plug that thing in there, and we can find out what our c is supposed to be. So let's rewrite, as we've done before, let's rewrite this derivative as f prime of x is equal to x to the -3, and take its antiderivative, which we'll call f. I know this says capital F. You can capitalize it if you want to, but remember what I said is if it has a prime mark, its antiderivative is just taking that thing off. Let's see, I'm going to add 1 to the exponent, so it's going to be x to the -2, divide by that new exponent, and then put a plus c. Let's rewrite this, make it look pretty. -1 over 2x squared plus c. So there's your general antiderivative, represents an infinite number of solutions. Now we're going to find the particular solution that goes through the points 1, 0. So we'll plug 1 in for x, 0 in for f of x, and see what the particular solution is. So I'll have 0 is equal to -1 over 2x squared. No, I won't, because we said we're going to plug a 1 in there. And then plus c. 1 does a whole bunch of not much. 0 is equal to -1/2 plus c. Add the 1/2 over, and I get a c value, a constant of integration of 1/2. Okay, you're not quite finished. You're almost finished. Last thing to do is just rewrite your equation. So f of x is equal to -1 over 2x squared plus 1/2. There we go. We found both the general antiderivative and the particular solution that went through the point 1, 0.